So welcome to this lesson where we will be understanding harmonic analysis in Fourier series. This is a part of engineering maths. So what is harmonic analysis? Harmonic analysis is the process of finding the constant term and the first few cosine and sine terms numerically. So the Fourier series of period 2 pi of a function y equal to fx is of the form fx equal to a0 by 2 plus summation n taking value 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx, where a0 by 2 is the constant term, a1 cos x plus b1 sin x is the first harmonic, and a2 cos 2x plus b2 sin 2x is the second harmonic. So we'll come to a few questions. Determine the constant term and the first cosine and sine terms of the Fourier series expansion of y from the following data. So x is in degrees and this is the value of y. So the interval is 0 to 2 pi. So we have made columns cos x, y cos x, sin x, y sin x. So cos 0 is 1. Again y cos x will be 2 into 1, which is 2, sin 0 is 0, and y sin x will be 0. Likewise, we have calculated for all the other values, and we have taken the sum of the y and the sum of the y cos x and the sum of the y sin x. So sum of the y is 8, summation y cos x is 3.4142, and summation y sin x is 0. So a0 is 2 by n summation y, that is 2 by 8. N is 8 here, there are 8 terms. Into summation y is 8, so this is 2. A1 is 2 by n summation y cos x, that is 2 by 8. Summation y cos x is 3.4142, that is 0.8536. B1 is 2 by n summation y sin x, and that is 0. So the Fourier series up to the first harmonic is given by y equal to a0 by 2 plus a1 cos x plus b1 sin x, that will be a0 by 2 is 1 plus a1 cos x will be 0.853x cos x. b1 is anyway 0. Coming to the second problem, obtain the Fourier series up to the second harmonic for, again you are given the set of values, you are given x in degrees and y. And again x lies between 0 and 2 pi, so the period of fx is 2 pi. Again a0 is 2 by n summation y, we have to find up to the second harmonic. So a1 is 2 by n summation y cos x, b1 is 2 by n summation y sin x, a2 is 2 by n summation y cos 2x, and b2 is 2 by n summation y sin 2x. Again n is 8 here because there are n observations. So we have the table x, y cos x, y cos x, sin x, y sin x, and we have cos 2x, y cos 2x, sin 2x, and y sin 2x. We have gone up to 2x because we have to calculate the second harmonic. So that will be, you can see here, cos 45 is 1 by root 2, that is 0.7071. Y cos x will be 4 into this, which is 2.8284. Sin x is sin 45, which is again 1 by root 2, that is 0.7071. Y sin x will be 4 into 0.7071, that is 2.8284. Cos 2x will be cos 90, which is 0. Y cos 2x is 0. Sin 2x is sin 90, which is 1. And y sin 2x is 4 into 1, which is 4. So likewise we calculate everything and we have the sum of y, the sum of y cos x, the sum of y sin x, the sum of y cos 2x, and the sum of y sin 2x. And now we have summation y equal to 16.9. We have these values from the previous slide. Summation y cos x is 5.5719. Summation y sin x is 7.4062. Summation y cos 2x is 1.6. Summation y sin 2x is minus 2.7. So a0 is 2 by 8 summation y, that is 2 by 8 into 16.9, which is 4.225. a1 is 2 by 8 summation y cos x, that is 2 by 8 into 5.5719, that is 1.393. a2 is 2 by n summation y sin x, that will give you 2 by 8 into, you will get it as some a2 is 2 by n summation y cos 2x. That is 2 by 8 into 1.6, which is 0.4. Again, b1 is 2 by n summation y sin x. That is 2 by 8 into 7.4062, which will be 1.8516. b2 is 2 by 8 summation y sin 2x. That is 2 by 8 into minus 2.7, which is minus 0.675. So your Fourier series up to the second harmonic will be a0 by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x, and when you substitute you get a0 by 2, 2.1125 plus 1.393 cos x plus 1.8516 sin x plus 0.4 cos 2x plus minus 0.675 sin 2x. We'll conclude with one more problem. Obtain the constant term and the coefficients of the first cosine and sine terms in the expansion of y. Now here it is not in degrees, you're just given the value of x and y. So again, if you have a table here, we have n equal to 6 here. So when it is not 2 pi, 2l is 6, l is 3, so period is 2l, and the Fourier series in this case is given by y equal to fx equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by l plus summation n equal to 1 to infinity bn sin n pi x by l. So up to the first harmonic it will be a0 by 2 plus a1 cos pi x by 3 plus b1 sin pi x by 3. So we have x pi x by 3, y cos pi x by 3, y cos pi x by 3, sin pi x by 3, and y sin pi x by 3. When x is 0, this is 0, and y will be, y is 9, so cos pi x by 3 is cos 0, which is 1. So y cos pi x by 3 is 9, sin pi x by 3 is 0, and y sin pi x by 3 will be 0. Likewise, we calculate everything and we calculate sum of y, summation y cos pi x by 3 and summation y sin pi x by 3. So your a0 will be 2 by n summation y, that is 1 by 3 into 125, which is 41.67. a1 is 2 by n summation y cos pi x by 3, that is 1 by 3 into minus 25, which is minus 8.33. b1 is 2 by n summation y sin pi x by 3, that is 1 by 3 into minus 3.464, which is minus 1.155. So your constant term is a0 by 2, which is 20.835, and coefficient of the first cosine is minus 8.333, and coefficient of the first sine is minus 1.155. You're just asked to find the coefficients here, so we stop at that. So that brings us to the end of this session, and thank you, and do subscribe to my channel and enroll for this course. Thank you.